you can kick it off now.
Oh, okay, great. So yeah, I'd like to welcome everyone to Cloud Native San Francisco meetup here. Looks like we have a kind of a small, cozy group, but that's great. So we usually talk about, kind of all things cloud, containers, microservices, et cetera, and in particular, more recently, a lot of security. So my name is Jim Walnum. I'm recently an ex-VP of infrastructure at Goldman Sachs. I've been in the financial industry for a very long time, back with such buy-side firms as Barclays Global Investors, et cetera, for that. So today we are very glad to have Rosemary Wang, who's developer advocate for HashiCorp. And she's going to talk today about kind of the I wouldn't say the adoption, but kind of the working into the processes and flows, security, building in security through automation with the tools, and in particular, of course, the HashiCorp tools there. And this is, for me, this is a very a topic that's kind of near and dear to my heart, because you find a lot of times when you go into particular startups, a lot of the focus, of course, is like on an MVP, et cetera, and the infrastructure is typically viewed as a second tier thing. So you get, typically they'll take a developer and they said, hey, anyone know infrastructure? And the guy's like, my cousin did infrastructure. And it's like, okay, you set it up. So what you get is, a lot with, as Rosemary mentioned earlier, with these, kind of managed services is defaults for the security, and there's no monitoring going forward. There's no review, automated review. It's not baked in for that. So as I said, to talk about this, Rosemary today, she's with HashiCorp, and she's has a lot of focus on kind of solving these intractable problems of building in process that contains the security, monitoring, et cetera, for that. She went to that small East Coast school called Princeton, and has worked at Bank of New York Mellon in the past for that, doing infrastructure. So without much further ado, I'd like to introduce Rosemary, or hand it over to her.
Thanks, Jim. All right, let me share screen. All right, so for those who, I know we have a small group today, so if you have any questions in the chat, feel free to just drop them in there. I'll run along and answer them. I'll be sure, for the recording, I'll be sure to read it out loud as well. But I'm always interested in what you folks have to say. So as Jim mentioned, today I'm going to be talking about security and policy configurations for infrastructure as code. Today is going to be mixed live code and slides. So if I flip-flop back and forth, I'll try to transition as seamlessly as possible. I also tried to bump up the font size. So if you have any trouble reading it or otherwise, let me know. I can always increase the size. Okay. So the story starts, as Jim pointed out, it's easy to just build infrastructure as code. I'm not going to go into the basics of infrastructure as code. There's many books on that. But the idea is that you usually start to define your infrastructure in a codified manner. And you can argue about whether or not this is a domain-specific language like Terraform, which is what's shown on this code snippet, or you can debate whether or not you should be using an imperative language or a programming language, right? But the idea is that you are going to be using a lot of this code to create and configure infrastructure. This example creates policies in a secrets manager. Most of the time when you do infrastructure as code, I don't know about you, I don't necessarily look at every single parameter. I copy and paste it from somewhere else, then research the parameters and then identify which ones I need to change. And so the point is that when you're doing this in an organization or within a team, it's really easy to say, oh, it works, I'll just copy it. This happened multiple times to me, in which I'll just look at my teammates' code base, or I'll find something online, I'll check it, maybe review it a little bit, and then I'll say, okay, I'll copy it. I'll modify a little bit. So I'll copy it, I'll paste it, except it's not fine, right? This is not an okay configuration for a couple reasons. The first is that the path here, if you're not familiar with Vault, HashiCorp Vault, that's okay. The point is that Vault is a secrets manager. It stores secrets, right, at certain paths. What I'm telling you in this policy is that you're allowed to access any token at auth token create. In Vault, this is a root token, or it could be any Vault token. So as long as you do this auth token create, you're able to basically update any token you want, right? The other thing that's not so great about this infrastructure as code is that the database path allows you to create, read, update, and delete. So you have a lot of access to this one endpoint, which means that if I have a PostgreSQL database configuration loaded in here, I can read out potentially an administrative username and password and then access the database, backdoor and access the database that way, right? So the idea is that it's not fine. This copied infrastructure as code isn't great to copy for everything, right? Sometimes you need this, but other times, do you really want to copy this 5 or 6 times across different parts of your organization, into different pipelines, into potentially even different applications? The answer is you probably don't want to do that, right? Not every application, not every delivery pipeline has to have, let's say, access to update a Vault token, and not everything has to have access to the database either. You might only need certain parts or certain configurations from that database. So anyway, the point is that now any kind of unintended intruder will get into your system just by some lax policy that you've accidentally copied across multiple places. Just like this cat decided to intrude into my house. This is not my cat, right? The point is that by accidentally opening the door, I've allowed a cat to wander into my apartment and wreak havoc and explore with whatever I want to. Now, in the past, I've learned different ways to prevent this. So today, what we're going to talk about are the 5 things that I learned as to how to prevent some of this from happening and ultimately scaling your security and policy configurations for infrastructure as code across your organization. If you do want to get in touch with me, follow up, et cetera, you can check out the links that I posted on here. My handle's on there. You can also check out other works, which as mentioned earlier, but if you were listening before this, you can also check it out at my website. All right, so here we go. The challenge is to deliver infrastructure and secure it, right? So you want to be able to deliver infrastructure really quickly. That's with infrastructure as code. And then you want to secure it at the very same time. There's usually this big argument between developer productivity and security. Our goal is to not make it an argument, right? You're supposed to balance the 2 interests. And you want to do it across many teams, right? Because the problem is scale. It's not necessarily delivering the infrastructure, and it's not just knowing the right configurations. It's being able to scale it across teams and still facilitate some kind of productivity whenever you're delivering infrastructure. All right, so here are the 5 things I learned, and I'll go through step by step. We'll divide it into 5 sections today, and I'll explain each of them in varying levels of detail. There's plenty of other content if you are curious to learn different pieces of this, and I'll direct you to some of those resources at the very end. All right, so the first thing that I learned was static analysis. Static analysis involves pretty much 3 steps in a workflow. The first is to update your infrastructure as code. The next is to ask the question, does that change adhere to our policy and security standards? And then if the answer is, well, yes, the change or the update does adhere to our policy and security standards, then release it to infrastructure. That's the happy path. The not so happy path is that if the change doesn't adhere to policy and security standards, then you go back and you have to fix your infrastructure as code. So this is the ideal workflow for static analysis for infrastructure as code, right? There are lots of terms for this, right? I call it static analysis because in the security space, there's often a division between static analysis and dynamic analysis. So I'm borrowing more of the security focused term today, but there's a lot of other kind of terms that you'll hear too. So I'm listing them here because you may have already heard them. First is shift left security testing. A number of folks probably talk about that. Fitness functions, which is more of an evolutionary architecture term. Evolutionary architecture is a concept that your architecture should evolve with the changes in your organization. So fitness functions help measure that. Security is one part of your architecture. That's why you would measure it as part of a fitness function. There's also testing infrastructure as code. There's a lot of generic infrastructure testing strategies that you can apply and just dive into a specific security or policy focus. So these are the main terms that you'll hear. All right. Really, though, static analysis for security in infrastructure, I'm being really specific about this, is divided into, well, pretty much one workflow, which is you have a configuration or a plan state, you get some JSON or metadata format, and every security testing tool, I have not found one that works differently, but every security testing tool just parses for the fields, checks the field values, and then asserts whether or not you pass or fail. every static analysis tool for at least the infrastructure space, the security testing space for infrastructure does this, right? So it extracts configuration, plan state, parses fields, checks field values, asserts pass or fail. It's literally a testing framework. But you can apply it to really specific use cases for security, right? Network policy is one. So that could be firewall rules, that could be load balancers, that could be certificates. Infrastructure configuration is something that's a little bit more nuanced, right? Sometimes you might have some metadata configuration that you've added to a bucket. We all know about these S3 bucket compromises and from the, like just from metadata itself and extracting from metadata services. So infrastructure configuration, if you have a specific one, that's a really good use case for static analysis. And access control and logging. I think we forget about this sometimes when we're doing our MVPs, but when you deliver infrastructure, you probably want to turn on the access control and logging mechanisms for each resource that you have. And static analysis for the security of that infrastructure is a good way to ensure that you're turning it on early and not later. Right, so we'll go with first this live code. Remember this policy, which is this secrets management policy. And I mentioned there were two problems with it. We'll talk about the first problem, which is the auth token create. This path allows you to get pretty much any token and update it. So we need to figure out a way to prevent this from happening. Not every pipeline needs it. So let's actually do this in a way that we pretty much just only restrict it to certain pipelines, or we only do it by default. You know, people aren't allowed to do it, right? So the reason why I'm doing this is that it's really just testing. So if you're familiar with testing and you're familiar with any kind of programming language testing framework, all I'm doing is parsing some kind of file and then checking values. So in this case, I have the vault policy. I'll pull up the vault policy so you can actually see it. You should see a screen that says code infrastructure. There we go. Okay. All right, so here's my policy, right? And we want to fix this, lines 9 to 11, auth token create capabilities update, right? This might be really simple, but for some folks, this is, whenever I've talked to folks who are doing this, they're like, oh, I never realized that this was actually something, a remote possibility. It's really testing. So what I've done is I've pulled in a library that will process the specific domain-specific language. So you can do this if, let's say, you have a Terraform file, if you have a CloudFormation YAML. There's also some CloudFormation linters you can use. So in any infrastructure code tool, there's some kind of testing framework that you can use. All I'm basically doing is parsing the resource. So resource, vault policy, pipeline policy. And that's pretty much it. I just write one test, and the test is assert path auth token create, right? So really when I run this, we can clear, and I'll run it again so at least you don't have to test. Okay. Really what I'm able to identify is saying, okay, vault policies do not allow vault token creation, right? And I'm able to assert that it's not in the policy, right? And it turns out this fails because it is in the policy. So I could delete it and the test would pass. The reason why I show this as a first go around is that it actually shows one very first practice that I talk about with a lot of the engineers that I work with. When you write these policies and you write these tests, you should be applying some clean code approaches, but more importantly, you should make it as descriptive as possible, right? In this particular situation, you want to make sure that someone who reads this understands that they're testing the vault policies and they don't allow vault token creation, right? That should be very clear. You can add additional error messages, add additional assertions if you want, but right off the bat, someone should understand what kind of policy this is. And standardizing the tests, right? With making sure you test, let's say, test this, and then the component, like in this case, vault, and then what part of the component, like policy, is something that's really important for someone to understand, especially if they're going to be reading through these tests and hopefully reading them, identifying, getting the knowledge that they shouldn't be doing this, and then updating their infrastructure as code. So once someone understands they can't, right, have this vault auth token create, you're actually creating an action for someone to take, right? Someone is empowered to say, oh, I'm not supposed to have this policy. Let me just take it out. And then once I rerun the test and add it to my pipeline, it's able to pass. So it's this constant feedback loop. That's the most important part of this, which is why I always demonstrate this seemingly simple example first. Okay. The second thing I learned is dynamic analysis. Dynamic analysis is really tricky. This has a lot of terms as well. You'll hear different use cases for it. The first is vulnerability management. So usually this involves scanning a huge footprint of your infrastructure environment and understanding whether or not you should be patching, updating for vulnerabilities. It's very similar. So if you have code, application code even, you would be scanning for vulnerabilities, right? If you have node packages, et cetera. Security scanning, another term, and remediation, which is basically going in and altering or updating the infrastructure so that it conforms to some kind of policy or security. This works the same exact way as static analysis. The only difference is the source. So the source of this is an active state or infrastructure API. You can think of this as like AWS's API, Google's API. If it's Terraform, you would be looking at the active state of Terraform. If it's CloudFormation, you're probably going to be actually looking at AWS active state. So in some regards, that's pretty much similar. You take the JSON or metadata format and your security testing tool does pretty much the same exact thing. If you're doing this on a Linux machine, for example, you might have an agent that is parsing through some of the Linux configurations, right? The point is in infrastructure, the security testing tools are always doing these three things: parsing for fields, checking field values, assert, pass, or fail. So you're able to implement this yourself even. The only difference between the static analysis and the dynamic analysis in terms of the workflow itself is that you run the dynamic analysis on a regular schedule. So you can think of this as monitoring. You can think of it as something more continuous, as some of my colleagues and some of the folks in the industry would say. It's more like continuous verification. You're always making sure that the active state or the infrastructure state is always conforming to security and policy. So you need both dynamic and static analysis. Someone told me once, like they only need to do this with static analysis, and that's false. There are some configurations you need to look at runtime, not or like early on in lifecycle. So you can't shift left something. So for example, let's look at dynamic analysis in this path database, right? The capability is create, read, update, delete. Remember I said before, you don't want everybody going in and retrieving database and create, read, update, delete, right? Let's say someone does have this policy in place. Someone copied it, put it in another repository, and now they can go access the database, passwords, and configuration. Well, you can say, okay, how about this? We can remediate this potential vector, right, by saying only pipelines with self-hosted runners on private networks should have access to configure or remove database secrets. So that means we're restricting who has access. That's access management, right? And that's a part of remediation or dynamic analysis. So this is a Sentinel policy. I'm not going to go into Sentinel too much. The point is, it's a way to understand the policy itself, but Sentinel will basically allow you to check certain request operations in Vault. It will check the policy dynamically. So what I'm basically able to do is say, okay, let me do a CIDR check rule. I'll only check anybody who is coming from a private network that I know of is a self-hosted pipeline runner, and they are the only ones who can access the database endpoint. So from a dynamic analysis standpoint, what this particular rule is doing is looking at active access management, right? And that's not something I can do statically. So as a result, this is able to enforce that policy, and that's more dynamic in nature. All right, let's see. Pause, looking at any questions in the chat. I guess there's nothing really. Okay. Right. There's a lot of tools in the space, and a lot of people talk about each of these individually because they can be pretty complex. If you're talking about vulnerability scanning, usually Snyk and Tenable are the ones that I hear. There are many more. Every time I do a policy or security talk, I get like 70 different tools and stuff that people suggest. Anyway, if you're doing vulnerability scanning, you can do Snyk or Tenable. Cloud infrastructure scanning. So this is more configuration or the active scanning for SETI or Cloud Checker, or some folks use as well. So cloud infrastructure scanning is doing it actively. So whatever is the active state, it will look at. And then there's the authorization piece. Authorization is like API authorization, for example. Can things access certain endpoints? Can two services talk to each other? In the microservices space, you might be more familiar with like auth. In this case, this is auth-z, right? So authorization, you can do it in the infrastructure space, specifically with Sentinel. You can also do it with OPA, or also known as Open Policy Agent. So there are a couple different pieces. Oh, all right.
So we do have a question. It's slightly off topic. I don't know if maybe we want to try to ask or answer it now, but somebody's asking for any resources of best practices for policies for someone who's just getting started with infrastructure as code.
Yeah, that's a great question. I have a huge, I have a set of links at the end and I compile them. There are a couple of resources. You can always check NIST because they have benchmarks for different cloud providers. The unfortunate part about the benchmarks is that they're not all pre-written. So for policy sets, pre-written policy sets, you may have to go tool specific. There's a link at the end that I include that has some information for Terraform, for example. The Terraform has a couple community tools on top of it for infrastructure as code that give you the best practices, like right out of the box. You get this policy set, and that policy set is a knowledge set that you can use and apply it to your infrastructure as you're getting started. So it gives you a good baseline to understand the best practices. But in terms of the more general best practices, some of the points that I showed before about use cases are usually the places to target first. But it heavily depends on your infrastructure target. So GCP is different than AWS, different than Azure, and any networking component. And it's also different depending on your tool as well in terms of implementation.
Excellent, thank you.
No problem. Great question. Okay. So the third lesson I learned, actually, this is pretty relevant to the third question, is modularization, right? So in order to get started with infrastructure as code and learn the security policies behind that, sometimes you need to have shared repositories. And these policies can be organized into different places, right? So most of the time policies are written in a document. And part of the struggle is trying to take those policies and security practices and moving them in a codified way. So repositories to share are usually divided into about 3 different types. The first is organizational policies, then there's organizational benchmarks, and then there's industry benchmarks. These are the 3 that I usually see. There's some that are more specific to region even, but that I classify as industry benchmarks. So examples of this is like an organizational policy. The policy I wrote about saying no one can access the database credentials unless they're coming from a pipeline runner, that specific kind of policy is organizational. An organizational benchmark might be something in the US, for example, like Sarbanes-Oxley compliance, where you're supposed to have like 2 approvers before it go to production. Organizations may not necessarily need 2 approvers, right? There may be something more specific. So that might be a benchmark that you have. And industry benchmarks, if you're in Europe, it'd be GDPR. It could be CIS benchmark, Center for Information Security benchmarks. Those different benchmarks will give you the knowledge to first get started and actually continue to build your infrastructure as code in a secure manner. When you divide these modules, right, because sometimes there's always the security policies or the organizational policies that you need, and then there's the ones that you probably don't, right? So it's good when you're building them to divide them into different modules. And it's good to divide them based on function, infrastructure provider, and business domain. If you're using something like GCP, right, Google Cloud Platform versus AWS, there's 2 sets of policy rules. They're not the same, right? There's no like policy language to rule them all. So you have to build it more specific to the provider, right? Similarly, if you have Ansible policies or security policies for configuration management tools like Ansible, you want to separate that out. In terms of function and business domain, this is also going to be different. Business domain is usually something specific to like you have a payments application or a payments microservice, and for some reason or another, it's determined to be PCI compliant, right? So that's going to have a different set of modules than just a plain old, service that maybe is just back end processing some data. Very different, and it functions also kind of falling into that bucket as well. Right, so I always use this reference as a way to show how you can divide it. This is one way of dividing it. I wouldn't say it's like the absolute perfect way to do it, but at least in my experience, this has been typically pretty decent. It allows it to scale, especially as you grow your infrastructure. There are basically 3 repositories. I'm not going into a monorepo approach. Like I'm not bundling all of these into one repository. Most of the time it gets a little dense. So what I like to do is I create a shared org policy, right, repository. And what this does is consolidate some of the more important pieces from an audit and security standpoint. So this is naming standards, tagging, really important. If you're not standardizing on tagging, you don't know how to bill properly within your organization. You also can't identify who's using what anymore, right? And what its purpose is. So tagging is a shared organizational policy that has to be moved top level. Billing is a big one. Secrets management, where any like large scale secrets, this could be certs, et cetera. Access management, this is also really important, especially if you have a couple of teams working on different things. You want to ensure that your access management policy is broad enough. Vulnerability management, I also move top level just because you do want to standardize in your organization, especially if you have like common images, whether it be containers or virtual machines. You also have runtime security as well. Then I divide a separate repository to infrastructure policies. Sometimes it references the shared organizational policies, right? So infrastructure policies could be like AWS, Azure, GCP, or Datadog, something like that. And then I also have yet another repository that is more business domain specific. So like I mentioned before, payments, right? Payments might be more business domain specific. It might have some specific industry requirements like PCI compliance. And I divide that into another one. So basically the nesting goes infrastructure policy references shared org policy, payments infrastructure policy references infrastructure policy, and some of the shared organizational policies as well, right? The idea is that you're able to pick and choose the policies that you need, but some of them are indeed required. So this is where you would work with security teams as well as compliance teams to understand which policy sets make sense to run against your infrastructure. Ultimately, when you add this to a build pipeline or a deployment pipeline, whatever you want to call it, CI/CD framework, you're going to have build, test, deploy, and then you'll have a security testing stage before you ultimately release it to production. So the subset of workflow, right, involves security testing and then releasing. Always functionally test first and then do the security test before production. Okay. Pipelines as code. We're almost to the end, I promise. Pipelines as code is a big one that we talk a lot about infrastructure as code, but in order for infrastructure as code to be secure and for us to ensure that we enforce the securities and policies on it, not enforce it in a like 100%, thou shalt not pass kind of way, but just to make sure that you at least have it running and there's awareness of these security policies, you need to have some kind of pipeline as code. The problem is that it's really easy when you build a one-off pipeline or you build it by hand to just have the security testing stage and just take it out, right? So when you look at that security testing stage, it's easy for me to go into, let's say, my GitHub Actions YAML and delete the security testing stage. In fact, I hate to admit it, but I've done it a few times. And in which case I don't have a security testing stage before production anymore. And that's not great, right? So trying to define pipelines as code will help enforce the security and policies gate, for lack of a better word, before production. Now we can talk a lot about continuous delivery or continuous deployment and the thought about like, okay, this is going to affect us from going to production, it's a manual configuration or it's a manual check, it's not gonna be, the point is in security, I would rather continuously deliver than continuously deploy, especially if there's something security sensitive for infrastructure, right? And I think there's a question in Q&A that kind of asks about this, like, how does this kind of security policy affect agility? And the answer is it will always, right? You're either going to spend time up front early on fixing it, or you're going to spend money and time remediating it. And at the end of the day, it's about understanding with your security. The best thing that I've done is be able to work with security teams and understand and evaluate the benefit, right? The cost benefit of adding this kind of thing into it, right? So for example, access logging, right? Access logging, adding a configuration to access log from a load balancer in AWS, for example, isn't that easy, right? You have to set up buckets, you have to set up all sorts of things. And that does affect your agility up front. But, if there's a security incident that happens and someone is telling you, hey, we're getting a really, a suspicious, at least in another system, we're getting some suspicious activity that's accessing the load balancer. What will happen if you don't have access logs for that? Well, the answer is you can't debug, you can't observe what is happening, and you're not able to remediate or address a potential security concern. And that costs time and that costs money as well. So in my experience, yeah, it does affect it a little bit in that it will stop it from going to production. But on the other hand, the funny story for me was like, if we had this in place, for if we had pipeline as code in place, we probably wouldn't have had a Bitcoin miner exploit our CI framework. That spent we could have taken the time and waited for an approval, right? And spent maybe 2 or 3 days fixing it. Instead, we spent 2 weeks trying to remediate take out the Bitcoin miner, assess what it was accessing, whether or not there was data that was compromised, and rolling out a new CI framework, right? So you have to weigh that the cost of it, but usually it affects it, but long term, it really helps. So, all right. And I know that's like the one way you can make it a little bit less painful, right, to have these kinds of security tests in your pipeline is to use templates, right? Templatize the policies you need. Make sure that you have the security testing stages, but they're just lenient enough. If there's something that's always blocking every single pipeline in your environment, then you know that that's not a great policy to have, right? You probably want to consider refining your security testing to exclude or add a more lenient policy overall. The other thing that will actually prevent any sort of help mitigate any compromises you make for agility is to run it asynchronously. And this works actually decently well. So what happens is, like, some folks who want to do continuous delivery, for example, but don't want necessarily the added overhead of security testing, what they'll do is they'll run the security test or policy tests asynchronously as such, and that will allow the release to continue. But if there's a security testing issue that comes up, then they will go back, they get immediate feedback to go back and fix it, and then they just continuously deploy. So the window by which someone could potentially exploit the problem is limited to the window by which you take to change the infrastructure in the first place. I know that's kind of tricky to say, but the point is that in this situation, you want to make sure that when you security test, you can run it asynchronously and just go back and make the updates as long as you're remediating them. There's a question about when we have defined pipelines as code in place, do we use static or dynamic analysis on them too? So static analysis, yes. Usually the static analysis or shift left testing, right, happens within the pipeline. You can use dynamic analysis in pipelines. Some of the ways that folks have done this is to schedule the pipeline to run with like a cron job for like a cron, not cron, but generally kind of like a regularly scheduled dynamic analysis. And some folks will do it like in pipelines, for example. So some frameworks will allow you to kind of run asynchronous jobs, not necessarily on every commit per se, but will run it on a certain timeline. And that will allow you to do dynamic analysis. And some dynamic analysis is covered by monitoring. So in which case you would have like a separate alert coming in from monitoring tools. But pipelines as code primarily focus on static analysis. Some of them do have dynamic analysis in place, and there are pipeline templates that you can define for, let's say, regularly scheduled pipeline runs. All right, last one is enforcement levels. So enforcement levels are really important because, again, right, you don't want to affect the productivity or the delivery of infrastructure changes, right? You don't want to just back them up. You always want to be continuously delivering them to production. So it's good to have enforcement levels. And I always say choose one of the following: hard mandatory, soft mandatory, or advisory. I'm borrowing these terms, they're not mine, from Sentinel, but I actually think they're better representative of kind of the mix of it. A lot of tools use interchangeable terms. I'll show you what I mean, but a lot of the tools use interchangeable terms. Really, this is, I think, the better defined terminology. The hard mandatory, we'll go back. Hard mandatory means that it must pass, right? If it does not pass, you will block pushing it to production, right? Or it's absolutely critical you remediate it. Soft mandatory is actually, I think, the more important enforcement level. Soft mandatory is a way for you to understand if there's a compensating control in your infrastructure. What I mean by this is that if you have, let's say, a container or virtual machine and it has vulnerabilities on it, not every vulnerability will be a problem. The vulnerabilities can only be exploited in certain situations, in which case you may need to ask someone who's a subject matter expert like your security team, and understand whether or not this like soft mandatory needs to exist, right? So soft mandatory has exceptions, right? So that basically means, okay, security team review, is there a compensating control that prevents this vulnerability from being exploited? If so, then let's go to production. And I think that's a really great way to think about a lot of security, right? And that sometimes you're always going to have some potential vulnerability in your environment, in your infrastructure configuration. It's a matter of whether or not you have a compensating control to address that. So soft mandatory is something I think, at least in the enforcement realm, is probably one of the most important enforcements that you can have, but not too many tools implement it. The final enforcement is advisory. This basically means this is a good practice you should have. It's not a bad thing if you don't have it, but hey, heads up, you should be doing it. So I'm actually going to show how you would do this with, here we go. Okay. So, oh, no, that's not the right one. 1 second. Oh, I'm sharing the right one, but I'm on the wrong window. Okay. So I have a policy and open policy agent. That's not exactly, the tool is less specific, right? But the more important thing will be enforcement levels. In the case of open policy agent, OPA, OPA has pretty much two different types, which is deny and warn. There's only one or the other, right? Deny means don't do it. Warn means, okay, like, you know, that you should do this, but it's not a failure, right? And in OPA, you can set the error code return to be deny all, if deny, you know, then return error. You can say with warnings, return error, right? So there's any number of permutations you can do with this. And more importantly, in a pipeline itself, right, you can also choose whether or not you deny or allow something when you add this to your pipeline. But I propose 4 scale reasons, right? Not because it's easy to put a warn and deny in the body of your code, but it's actually really hard to communicate across your team that something is a little bit not a 100% a deny or 100% an allow, right? So sometimes it's not so black and white. There's like the shades of gray in between, in which case you have to build an exception system. So I'll run this just so you have a sense of what it is. But basically right now I have all these deny policies. The policies themselves are checking, well, a JSON file. I'm not actually using any particular, I'm not using Terraform. I'm actually just using an API response. So really, this is not even necessarily infrastructure as code, but you can still apply the same approach. This is using, let's say, console API. The console API has a source and destination name. This is basically like a firewall saying things can connect to this, X can connect to Y can connect to Z, X can't connect to Z, right? So this is more of a firewall rule kind of approach. But basically, I'm doing the same thing, parsing the JSON. That's really all it comes down to. And in the JSON, right, I am trying to look for certain fields. So for example, traffic should only be allowed from web to app. Currently, it's web to database and app. That's a deny. That means I shouldn't have that. Intention should deny all traffic by default. Currently, it's all allowed. Also not allowed. And the number of intentions should be 3, currently 4. Now, some of these rules don't really make any sense, right? Like the number of intentions means firewall rules, right? Equivalent. It doesn't, I mean, people are always going to add them. So this isn't a fantastic policy to begin with. And in that case, maybe I'll just set it as advisory instead, right? We think that it should be 3, but if you have more, that's okay, at least in this case. And in which case, when I run OPA again, it will set it as warn. The error code I can set to say, fail because it's denying, but if I throw a warning, that's fine. At least I'm aware there's a warning and I can parse that later. So that's the first thing. But let's take a look at this web app, right? Traffic should only be allowed from web to app, currently web to app and database, right? And maybe I'll talk to my security team and then tell me, oh yeah, like it kind of makes sense. App could have access to the database, in which case this isn't a policy we globally want to enforce. In your case, in your team's case, we'll make an exception, in which case that's a soft mandatory. So what I've done is implemented a function in OPA that using Rego, which is the language, the domain specific language, to create a soft mandatory. So what I'm able to do is quickly add a soft mandatory. So as long as it's not a soft mandatory, That's kind of the interesting thing about Rego policy language. There's a whole, you could do a whole talk on this. But as long as it's not soft mandatory, then, I expect it to pass. So if I run it again, you'll notice that, there's still a deny, which doesn't really help me. But let's see, web app. Okay, well, not today. 1 second. Live demo today. All right. Okay. Well, it's not going to work. But regardless, the point is that, yeah, it's not, for some reason, sometimes Rego, by the way, for those who are curious, Rego Gatekeeper, the OPA Gatekeeper is fine, but Rego is still under development at times. So don't be alarmed.
Yeah.
There are some pieces to it that are a little tricky.
Always hard to keep it straight.
Mm-hmm. But we're going to revert to, here we go. I know what I did wrong. Okay. Intentions, right? So the key is that intentions, what I've done is create an exceptions list, right? And in your team, it's a lot easier to create an exceptions list and list the specific policies that you choose for it to be an exception, right? So if you're bundling these shared policies, it's not actually half bad to put them in an exceptions file to say, okay, these are the ones that we expect the exceptions on. So you can do this on resources, for example, S3 buckets or AWS resources, GCP resources. You can just add an exceptions list, add the kind of resource or the name of the resource or the identifier of the resource. And it will actually allow you to choose whether or not that's a soft mandatory. So in this case, it will work this time because I've actually added that correctly. And the big difference is that I actually added another rule, which is the traffic should only be allowed from app to database, right? Currently web app to database, right? So this might be something that's a better expressed kind of policy rather than saying, check that web can only go to app. The reason why I wanted to at least demonstrate this at least the exception, is that it's really hard to implement exception handling, not exception, but soft mandatory logic in policies. So you do have to consider either having utility functions or sort of a larger exceptions framework so that you document the ones that are specific to your team and to your application. And then you'll be able to make those. So you still will be able to maybe say warn. You could put this as a warn. But overall, in Rego specifically, this implementation of a soft mandatory function is something that you would just add to each individual rule. So you can abstract that out and run it. But at least for this case, it's more, I at least wanted to show that you have the logic and you do have to implement that specifically within Rego. And it was my mistake. It does work. It's intentions. It's just not intention. Okay. I know there is a question. Let me go back to slides. Okay. Is it good practice to decouple policy evaluation and enforcement? For example, we have allow, deny, and exception in the case of OPA example, and have enforcement for only allow and deny rules. I do think it is actually important to decouple the two because it's not always some team, there's always going to be an exception. And some teams will always try to find a way around it anyway, right? So decoupling the evaluation and the enforcement piece will allow you a little bit of flexibility to identify which ones are most important for a certain situation, right? So not every application or infrastructure around an application, for example, needs to be PCI compliant. You only really want to do PCI compliance as a whole beast to implement or a beast to ensure. And then in that case, you only want to do it on a subset of your infrastructure, in which case it helps to decouple the actual policy evaluation of that from the enforcement, right? Because some portions might be PCI compliant and others might not have to be, in which case evaluation and enforcement make it easier. In the case of the OPA example, and have enforcement for only allow deny rules. Yeah. So enforcement is only only required for allow deny. At the end of the day, someone is going to say, okay, I've evaluated this. I've made this a soft mandatory. Let me add it as an exception. So I think that in this particular situation, what you'll at least identify is that sometimes there's still an automated way to identify exceptions or soft mandatories in this environment. And then that serves as the enforcement piece. So from a workflow standpoint, there's 100 different ways to do it, but I separate the two, usually just because it allows the flexibility across multiple teams and different kinds of infrastructure. All right, so summarizing, these are the 5 things I learned. I'm not gonna go through all of them again, but the idea is that with these 5 things, you can at least start to implement security and policy within your organization in a standardized way, right? So you can start by developing and delivering the infrastructure. That's perfectly fine. But the problems that we're reaching now in infrastructure as code is not, in infrastructure as code specifically, is not really about infrastructure not being able to be automated. The problem is that we can't work on it or collaborate on it easily across our teams, right? And as we grow our footprint, right? So if you're copying and pasting a bunch of infrastructure as code for customer deployments, for example, that has a whole secure, do you have security policies around that based on your customers, benchmarks, policies, and standards? And it helps to have that in place, right? So the demos and tools today, just for the sake of time, I skipped one of them, Inspec and Docker. I have a link to Inspec and Docker, so you can take a look at that. Inspec does a great job of showing different controls and how you can select and control for each of them. And Inspec also has a really great soft mandatory, hard mandatory kind of approach to it as well, so you can always use that as a reference. All right, so general references, I mentioned NIST benchmarks before. NIST is a great way to understand what benchmarks are available out there from an information security standpoint. The examples I showed today are in 3 different repositories. And there's also a list of policies code with security scanning. I attached that there. That list has a number of tools as well as policy sets that you can take a look at as well. With that, I think that's all for me. I appreciate everybody tuning in today, and I guess we can have open Q&A now.
Yeah, that's great.
That's great.
Thank you so much. Go ahead, Jim. Sorry.
Oh yeah, no worries. I was just going to probably say the same thing you were. Yeah, thank you very much, Rosemary. It was wonderful. Yeah, and if you have any Q&A, please feel free to post it in the Q&A section, and we can follow up with that. But we'll wait and see here. Yeah, but if not, I'd really like to thank everyone for attending this Cloud Native San Francisco presentation. We'll hang on for a few more minutes to see if there's any questions coming from that. And Josh, do we have is there the next event planned at this moment?
Yes, there is. Let me go ahead and share that real quick. But as I'm doing that, Rosemary, I'd be curious about you mentioned the Bitcoin miner. What happened there? I think I heard about that. Was it public? Did you guys write about it?
Oh. No, so it was not publicly. It was not publicly. It was not at HashiCorp. So it was previous experience. But there was. So HashiCorp did have, the CodeCov, I think vulnerability. We were very fortunate in that it didn't affect really anything. And that was all rotated. But in the Jenkins situation, the CI/CD framework. So Jenkins is a really powerful CI framework. And to its credit in the open source community, right? There's always, there's always a number of folks who will disclose and report CVEs. But the problem is not necessarily people reporting CVEs. It's whether or not someone actually reads the CVEs. And as it so happens, the CI framework had a remote code execution vulnerability, CVE, that was reported in a previous plugin version, and we were using the plugin version. Then the remote code execution was exploited by a Bitcoin miner because we actually had a security group in AWS that was open. Not fantastic. And so we had a security group that was open because of dev. It was just some dev experience that someone was trying to figure out and they were debugging. So to expedite things, they opened it up. And the result was that someone was allowed to inject this remote code into the Jenkins pipeline. It created basically this process that would go with Bitcoin mine. And as a result, we had to take down the entire CI framework, which meant that all development was halted for about a week and a half. To be rebuilt. And the vulnerability was remediated. So we did close off security groups, et cetera. But that was a situation in which the vulnerability existed. There was no compensating control because we had the open security group, right? And we learned a couple of things. The first is that we probably should have had some kind of, we did actually implement this, later, but we had some we added a dynamic analysis tool to check the security groups and monitor them on a regular basis to make sure no one was just opening them willy-nilly. And then we also had additional checks, static analysis written to ensure that plugin versions, right, were of specific versions that we knew were, for the most part, secure. So there are a lot of things that we learned from that, even individual experience. But
sounds like it.
yeah, but it was a rude awakening for a lot of people, because it was like, oh, well, we spent 2 days, creating the Jenkins, creating Jenkins, setting everything up. And yeah, sure, people were pushing, people were delivering. That was great. But then we halted all development for a week and a half to fix it all. So, it was a cost that we realized we weren't willing to take after that.
Oh, that's quite an
Amazing.
experience. Yeah. So, Rosemary, I had a question. So, the Sentinel and OPA, right? These are all relatively new policy tools, right? So, how was this kind of scenarios handled before these tools were existing?
Yeah, it's a great question. It was the original user programming language. So in some cases, you would use specialized tooling, and that was written for the platform target. So that could be GCP, that could be AWS. Anything that we couldn't implement in a tool prior to a policy as code tooling for infrastructure had to be done through programming languages and parsing. So you would have to implement your own abstraction and functions to parse anything that you wanted to. For example, Kubernetes didn't, when early on Kubernetes didn't have conformance tests. So you would have to write your own, whatever platform framework you wanted to use. I showed Python today. That's the traditional way to, in the security space, that folks would use Python to script out some of the stuff. But most people now use the programming language of their choice. It could be Go, it could be Java.
It was very helpful. Good.
Looks like we have one question in there. Do you see that, Rosemary?
Yes, I do.
Yeah.
Yeah. So cloud custodian for infrastructure scanning, it's kind of like Forseti, but it has more flexibility in the DSL. So I've heard a lot of folks have used cloud custodian. I used it very, 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 very early on. Before it was even officially like joining the sandbox. I think it's now CNCF sandbox, as I recall now, but it was like before it was a sandbox. It's pretty powerful. And at the end of the day, any kind of DSL, anything that has a DSL and the policy sets for you to use out of the box will be helpful. The problem with a lot of the tools today, policies code tools, a number of them don't offer policy sets, right? So you don't really get a good idea of what the best practices are. So you could create a load balancer, but you still need to create the rules to identify whether or not that load balancer has the right securities and policies in place. So let's say like it's an internal load balancer, right? Or it has access logging enabled, or you're you've got TLS, it's got TLS and enabled on it, right? So those things are not in every tool. I believe Cloud Custodian the community has some rule sets, in which case that it's very useful. I'm trying to remember, because like all of them start with cloud as a prefix. So I'm trying to remember which cloud asterisk has the policy sets pre-written. And I think Cloud Custodian has a big enough community that has, I think, AWS rules, but I don't entirely remember. Hopefully that helps.
Awesome. So I think that's it for questions. And let me share the next event real quick. Jim, let me see if I can pull that up. Can you guys see that?
Yep.
Yep. Okay. So this is our next event. It's going to be on Wednesday, July 28th, and we'll be sending out some information. This is going to be in the morning again. So and this one's probably going to be the longest meetup that we had. It's about an hour and a half. And so we have some of the main contributors from CNCF incubating projects here. And there's lots of updates. And they're just going to give us kind of the latest greatest updates and where things are today and where we see things going in the short term here within the next, say, 6 to 12 months. So we're looking forward to that. Yeah, and so that's all confirmed and we'll send that out. And Jim, thank you so much for hosting our event. Great job. Rosemary, thank you so much.
My pleasure.
And I hope you come back again. Say yes.
Yeah.
No pressure.
Anyone who wants to know more about something, let me know.
That's great.
That's fantastic. Okay, everybody, thank you for coming and we'll be in touch. Take care.
Thank you,
Thanks all.
Jim.
All right,
Bye.
everybody. Bye.
Bye.